Hi, this is Marshall Moyo, a mathematics teacher. So over the years I've noted that people have got a few challenges when it comes to the concept of linear programming. So I've thought of coming up with this lesson so that we explain a few things, illustrate some procedures as to how you begin up to getting all the answers without aiming blindly and hoping to get the answers by chance, but using the actual and the appropriate methods with full understanding. So what we're going to do here, we will list down some objectives. So take note of these objectives. By the end of this lesson, you should be able to do the following. Right, our objectives. Right, number one, you should be able to extract the inequalities. You should be able to extract the inequalities from the given situation. Right, two, you should be able to draw an LP graph, linear programming graph, and outline the feasible region. Alright, three, you should also be able to determine which side of the line are you to shade. And then four, you should be able to evaluate your objective function. Right, so at this stage you're asking yourself, what are all these things? What is an objective function? What is a feasible region? What are we talking about when you say which side of the line to shade? For starters, what line are we talking about? Okay, right, so we will get into that in a moment. So first of all, let's just answer this question. What is linear programming? Okay, what are we talking about here? Right, so this is a mathematical technique which is used to represent a real life situation by way of a graph to find a solution. So by now you know that as mathematicians our main aim is to solve problems. We find solutions. So that's what linear programming does. So I'm not going to put all this down in the form of notes, but I'll just explain briefly. So linear programming mostly is used in business setup, but as its conception came about during the time of war, I think World War something, if not before that, or it was made prominent due to high necessity during the one of the world wars. I'm not sure which. So it is a tool which helps people to make informed decisions, specifically on resource allocation. Right. So, and it works best if we have got what is we can call a two-part business, or a business made up of two major items, because here we are going to be drawing our graphs on X and Y, which is a two-dimensional graph. So it will only require a maximum of two things. When you have one thing, you don't need to make a decision, you just go with it. But if you have two now, your decision is how much of resources can I allocate to business enterprise A, and how much of resources can I allocate to business enterprise B. Now, we are also going to be faced with the scarcity of resources here as you allocate your resources. So your resources include things like money, time, labor, space, among those things. So when it comes to money, someone can have only so much of capital. If it comes to labor, one can only have either a maximum number of people working for them, or combined those people are able to work a certain number of hours in a day, or someone has so much in terms of floor space. So all those are what we call constraints. So with linear programming, what you are trying to do is find the best operational numbers for your two business enterprises given all these constraints or challenges you are facing. Now, in any business, we cannot consider all challenges, in this case all constraints. So we might maybe consider only those that are important, and then the rest we hold them constant. And in business or economic terms, we say we hold them at ceteris paribus. So at any given time, maybe you only consider 3 or 4 constraints, then the rest maybe they are minor, or you are saying they don't have much impact. Now, we saw also in objective number 4 there, we said you should be able to evaluate your objective function. So we're talking of business here. People in business are trying to achieve either of two things or both. 1, minimize costs. 2, maximize revenue or maximize profit. So you're either maximizing. If you're maximizing, it's either revenue or profit. If you're minimizing, it's either you're basically minimizing costs. Right. So your objective function could be you're trying to maximize, like after you've decided on both enterprises, you're looking at the numbers that will give you the maximum profit, and then or you're looking at the numbers that will give you the minimum profit. By numbers, I'm simply saying for maybe enterprise A, how many of business A how many quantities, or how much quantities of business A should I allocate, and how much quantities of business B should I allocate in order for me to realize my goal. So that's what linear programming is all about. So you take someone's problem, they give you their numbers, and then you take everything, you model it in using straight lines, graphs, then you come up with a solution, and then you advise them. You are best served when you handle this with this and this and these numbers. So in an overview, that's what linear programming is all about. Now there's something that I just said is feasible region. Okay, so I'll just illustrate that by way of a diagram. I'm assuming that at this stage all of us have seen something that resemble a diagram of linear programming. So you'll be having something like this. Alright, so after all, you have some lines, you have another line going like this, you have another line going like this, and you see this side is shaded like this side is shaded like this, and then this side is shaded like this. Right, now this region labeled by R, that's what we call the feasible region. We say it's feasible region because all these shaded sides of the lines are what you cannot operate with. So after you have eliminated all these, you are only left with this polygon. Sometimes we call it a solution polygon or a feasible region, which means any numbers, set of numbers that you get. When I say set of numbers, it means inside this region you have this number representing X, you have this number representing Y. Right, so this is a number set, this is a number combination. So for enterprise A maybe is 10, for enterprise B maybe is 12. So you are saying 10 of X and 12 of Y, those are numbers that you can work with, because you find that number set inside the feasible region is possible to operate, which means all these three constraints allow you to operate, or they are satisfied there in that region. So basically the feasible region is a region in which all your constraints are satisfied. If you have a problem, like you have a maximum amount of money that you are prepared to spend, inside the feasible region you cannot go beyond that amount. If it's number of hours that you cannot work beyond, inside the feasible region you cannot exceed those number of hours. If it's a case of floor space, inside the feasible region you cannot exceed that floor space. Now as it is a region, it will have so many points, but there is only one point in that region that maximizes or minimizes your objective function. So at the end of it all, you are looking for that point. So the steps are: extract your inequalities, and then draw your linear programming graph, and then as you draw your linear programming graph, you do your shading. Once you shade, you will get your feasible region, and after you get your feasible region, now you can search for a point which satisfies your objective function. Right, so that's what linear programming is all about. So as we said, you take your situation and model it in terms of straight lines. Now in objective number 1, we see that there is a talk of inequalities. Now I'll just give an illustration. Let's say I want to start a business, but available capital is $1,500. So it means everything I might need to buy, services I might need to pay for, in total cannot exceed 1,500. So it means my costs to start this business or to operate this business must be less than or equal to 1,500. So put written down, that will means my total cost must not exceed 1,500. So this is where we will be creating the inequalities. If I'm saying to run my business I only have 45 hours a week, so it means my total time must not exceed 45 hours. And then if I'm saying for my business to be viable, whatever I am dealing with, it must not, in total, must not be less than 100. So that's another inequality. So my total number of units must exceed 100. So all these give me inequalities. From these inequalities, that's where I now draw the lines. And then these lines are these ones that you see here, this one, and this one. And then now those lines give us the feasible region. Then the feasible region gives us our solution, the optimizing set of values inside the feasible region. So now I think I've explained all the basics, feasible region, objective function, where the inequalities come from, and then now we are left with the side of a line where we shed on. Now we see that once you draw your line from this illustrating graph, you can see that once you draw a line, you will always have two sides of the line. So there is a way you decide to eye shade on one side of the line or the other. It's not like thinking, oh, let me shade this side because it looks like I should shade this side. No, there is a way to determine which side to shade, and we'll get to that in a minute. Alright, so just to go over it, linear programming is basically a tool that will help you make decisions on how to run a business enterprise that only has two parts. Right. So if it's a farmer, maybe we're saying it's a farmer who's deciding on how to plant his tomatoes and potatoes. So his constraints could be he has 40 hours a week. Another one is he just has 40 planting lines, like 100 planting lines altogether. That's another constraint. So it means how many lines of potatoes, how many lines of tomatoes he plants, he can only make it up to 100. His money, that is for chemicals, for seeds, for labor, maybe he has $500. So it means he cannot exceed $500. Now, all those maximum, caps, or minimums, that's where the inequalities come from. So you will see. So from here, I will show you how to extract the inequalities. Then from there, draw the graphs. It's all about in the words, in the language. Just look at it. From there, everything will be easy. Right. So let's move forward now. Try to go on and see what we can conjure in the next section. So I think we have exhausted most of the important things that we needed to do. So let's go straight and look at a question, and we get on with the extraction of inequalities and everything. So here is a situation. Right. It says a tennis playing a tennis playing golfer has 15 pounds. Now, so if you look at this, it means there is no way you will find him spending 15 pounds 10 cents because he has 15 pounds. So which means whatever he has to buy, it must be 15 pounds or less. That's his situation. Now, he has 15 pounds to spend on golf balls, and golf balls will be represented by letter X. They cost €1 each. Sorry, I said pounds here, it's euros. And tennis balls, which will be represented by Y, and they cost 60 cents each. Now, so we see now that he has a constraint of the total amount of money he has coupled with the cost of each ball. So we must come up with an inequality on that. And then he must buy 16 altogether. So this one again tells us that we can come up with an inequality as well pertaining to that. We'll be back on that one shortly. And he must also buy more golf balls than tennis balls. That's another inequality. Right. So we will deal with that first and then come back to answering the questions. The questions are, what is the greatest number of balls he can buy? After using them, he can sell golf balls for 10 cents each and tennis balls for 20 cents each. What is his maximum possible income from the sales? Right. So now when we say X represents golf balls, we're basically saying he's going to buy X golf balls. X representing X, that's the frequency of the golf balls. He can buy 1, he can buy 2. So X can either be 1 or 2 or 3 or 4 or whatever, but we don't know. So we're saying he will buy X golf balls. Now, if he buys X golf balls, how much does a golf ball cost? It costs €1. Okay, so let's look at this. If you buy, in that case, if you buy 2, it will cost you €2 because it's 2 times the cost. If you buy 5, it costs you 5. So basically, the total amount that you're going to spend will be €1 times the number of balls you buy. So in this case, we are using a general value X. So he will buy X balls for €1. So that now will give us €1. Now, this is in euros and then this is in cents. So personally, I'll prefer to put everything in cents because yes, you create a sensible sentence if everything is in the same units. So now I will treat €1 as 100 cents. Then now it means one ball costs 100 cents and I buy X of them. So it means the total amount I will use for golf balls is 100 X, which simply means 100 cents times the number of balls. Now I'll combine this with the amount I'll spend on the tennis balls. The tennis balls are the Ys and they cost 60 cents each. So if I buy Y balls at 60 cents each, that gives me a total amount of 60Y. Right, so this is the amount of money that I spend, but I've got only €15, which will be 1,500 cents. Now, this amount, this is what I will spend, right? And since I only have 1,500 cents, my total amount that I will spend must not exceed 1,500. So it means 100x plus 60y must be less than or equal to 1500. So that's my first inequality. So I believe now we can begin to see that things begin as a narration, a story, a statement, but things are coming down to familiar mathematical situations. Now, I believe that we've done some divisions, some simplification of fractions or anything, common factors, factorizations. We can see that 160 and 1500 have a common factor, which is 20. So we can divide throughout here by 20, divide by 20, divide by 20. We simplify our inequality. It will give us 5x plus 3y is less than or equal to 75. So we have our first inequality here. So objective number 1 is now being put into test. We are seeing, can we be able to do that? Now let's come to the second one. It says he must buy 16 altogether. That is, he must buy 16 balls altogether. So this statement omitted something. He must buy at least, he must buy at least 16 balls. This inverted should be here, otherwise we have some funny English. He must buy at least 16 balls altogether. So what does that mean? He will buy X golf balls and he will also buy Y tennis balls. All together, these must be more than 16. So you will buy X golf balls, then plus Y, and these must exceed 16. So this must be greater than or equal to 16. No problem if it's 16, but it cannot be less than 16. That's the issue. That's our inequality number 2. And then the last one, it says, and he must also buy more golf balls than tennis balls. Remember, golf balls are X, tennis balls are Y. And this means there must be more of X than Y. So we can write it as Y is less than X. That's our inequality number 3. So people must be asking here, why did you start with Y? Technically, if we are saying out an equation or an inequality that involves both Y and X, Y is usually the dependent variable, so it comes first. Y depends on X. Right. So these are our inequalities that we are going on now to draw a graph and then try to solve all of these athletes' problems. Alright, so we will take our inequalities to the next page where we will do our drawing. Right, so let's get to it. So our inequalities are 5x plus 3y is less than or equal to 75, and then x plus y is greater than or equal to 16, and finally y is less than x. Now here comes the stage where we need to pay great attention, because now that's where we are now gravitating towards a graph. So in the graph we will first draw the straight lines. Straight lines are represented by equations. So temporarily our inequalities will turn into equations. So we will draw the line 5x plus 3y equal to 75, and then here we will draw the line x plus y equals to 16, and then here we will draw the line y equals to x. Now what I usually like to do is I draw the table of values. X, Y, and then I just say, okay, what will be X, what will be Y when X is 0, and what will be X when Y is 0, and then same applies here. Pardon my very straight lines here. I hope this won't disturb your viewing. X, Y. Now what will be Y when X is 0, and what will be X when Y is 0? This one is a very common line, so I'm not going to make a table for it. Now, so let's come here. When X is 0, we substitute 0 here. So all this becomes 0. So we're left with 3y equals to 75. When we divide both sides by 3, we see that our y is 25. And then when we make y 0, we're left with 5x equals to 75, and that gives us x equal to 15. So we know that when x is 0, y is 25. When y is 0, x is 15. For this one, it's clear. Once you set x equal to 0, y is 16. And once you set y equal to 0, x is 16. That's it. So next thing now, we just need to draw our graph. And then that's when we go on to the concept of determining now where or on which side of the line do you shed. The moment you shed, you get your feasible region. Everything is done. Right. So let's put a grid background. Right, and then now we need to draw our straight lines. We can see that maximum, our y goes up to 25 and our x goes up to 16. So we'll see what we'll do. Drawing my graph now. Okay, right, so let's label it quickly. Alright, going up, I'll use 1 square for 2 units, so this will be 4. This will be 8. This will be 10. I'm trying to manage my space. No, that's not 10. This is 12. This is 16. This is 20. This is 24. Right, so that will make this one 26. This is y, and this is x. And this side, 1 square will represent 1 unit. So we have 2 here, and then we have 4 here, and then we have 6, and then we have 8, 10, 12, 14. We need some. Around like this is not. Okay, will be be here the whole day trying to match. If we didn't get it the first time, we won't get it forever. Alright, so this is 16. So everything we need is contained. So we start with our line, this one. Right, so this one passes through 25 and 0.25. So 0.25 is here, midway between this square, if you see our scale correctly. And then this side, it will pass through 15.0, which is here. So if we were to draw that line, it will come something like this. And this line also passes through, when x is 10, no, when x is 12, y is 5. That will help me. So we can draw our line now. And then it will go something like this. Okay. Right. Now I want us to go straight and decide which side to shade. So I will teach you a very easy technique on the decision for shading. It makes your life very easy. Use the 3 points. Use either 0, 0 or 0, 1 or 1, 0. These are the points you use to determine which side to shade. Now, when you're deciding, if your line doesn't pass through 0, 0, use 0, 0. Like this, our line does not pass through the origin. That's 0, 0, which is the origin. So we can use it. So how do we use it? If we look at our inequality here, our inequality tells us that the left hand side is less than the right hand side. So that is, the left hand side is less than or equal to the right hand side. So what we just need to do right now is to say, what if we take 0, 0 and substitute it? When we say 0, 0, the first number represents x, the second one represents y. So 0, 0 means x will be 0, y will be 0. We substitute it in our inequality here and see whether the result will be the same. So we have 5x plus 3y. This side we have 75. If we put 0 here and 0 here, this whole thing becomes 0, and this side we have 75. And then obviously 0 is less than 75. We can all see that. And if we treat it with the left hand side, right hand side, we can see that the left hand side is less than the right hand side. So this is what our inequality says, and then this is what we get by substituting this point. So this point is giving us a consistent result to what we already had. Once we substitute it, it still tells us that the left hand side is less than the right hand side. So what does that mean? It means that point came from the wanted region. And in inequalities or in linear programming, you shade the unwanted region. Remember earlier I said there is only 2 sides of a line. If one is the wanted, then it means the other one is the unwanted. So then it means this side is the unwanted region. So your shading is just by putting some line strokes like that, that will be enough. Just the line strokes like that, that will be enough. And then next we are to draw this line. So this line passes through 16, 16. So it will pass through this point, and then it will also pass through this point. So we draw our line. Where are we? Find our line and minimize the density of the line. Then we come here, pick our line, and off we go. It must pass through here. There we go. Now we go back and we're trying to make our decision which side to shade. Again, our line does not pass through 0, 0, so we will use 0, 0. And our line now is x plus y, and this side there is 16. And this side there is 16. On its own, our line says, there is our line. The left hand side must be greater than or equal to 16. The or equal to doesn't concern us here. We are only interested in greater than or less than. Now, let's substitute 0 here and 0 here. We get 0 plus 0, which is 0. Compared to 16, 0 is less than 16, which means that the left is less than what? The right hand side. Let's juxtapose it with what our inequality says. This is what our inequality says. This is what the point 0, 0 says. The point 0, 0 says the left hand side is less than the right hand side. Okay, this was supposed to be R here. Right, so now this is in disagreement. This is what our inequality says. This is what 0, 0 says. So if they are in disagreement like this, it means the point we used, reference to our line, is coming from the unwanted region. So everything on the side of 0, 0 is the unwanted region. So it means we will shade this side. There we go. We will shade this side. So all below that line we shade. So we have shaded with reference to 2 lines. Now our next line is y equal to x. Now the line y equal to x just have less than. It does not have or equal to. That makes it a special kind of a line. And in that case we draw a dotted line. Right. So this line passes through the point 2, 2 and then 4, 4, like that, like that. So when we draw our line, we must get something like this. Take note that our graph has different scales, so don't be surprised. Alright, there we go. Hope we pick it right. Okay, so it must pass through like that. I think it's perfect. Right, no complaint. Now this line passes through 0, 0, so we can't use we cannot use 0, 0 in this case, because it will give us equal to and we can't decide. So we can use the point 1, 0. It's very obvious, it's clear, there it is. This is 1, 0. Now we use 1, 0 and we can see on which side of the line it is. So once we use 1, 0, we will know. So our inequality tells us that the left hand side, so this was the first one, this was the second one, and this is the third one. The third one tells us that the left hand side is less than the right hand side. Now let's see what happens. our inequality has y this side, it has x this side. So we are using this point. This point is 1 for x and 0 for y. So it means 0 for y. There's 0 here and then there's 1 here. So which makes the left hand side less than the right hand side. So it means the left hand side is less than the right hand side. So which means this point is on the wanted region, which means the other side is the unwanted region. So we shade this side. We shade this side. Okay, right. So after doing this, technically this line means that all this is shaded. We just use short line for neatness. Now you can see that this is the region which remains unshaded. This triangle here. That's our feasible region. All this work we've been trying to obtain this region. Okay, so that's what we wanted. So in this region, that's when we try to answer the questions. We have obtained our feasible region here. So let's go back to the questions and see what is it that we are required to find. So the question says, what is the greatest number of balls he can buy? Okay, right. So let's go to the graph. Right. So the number of balls he can buy are inside here. Alright, I told you that this is supposed to be a dotted line, so I must cancel out some parts of that line so that it becomes a broken line. Otherwise this would be a fake diagram. Alright, this is supposed to be a broken line. Right, so his solutions include something like this one, which is 9, 8. There is this one here which is 10, 8. There is this one here which is this is 10, 10, 6. And then there's this one here which is 11, 6. And then there is this one here which is 12, 4. And down here we don't have any more points. Right. Another important thing that you should know is you do not take points on a dotted line. You only take points if it's on a continuous line. Now this point we said it is 10, 9 for x and 8 for y, so that gives 17 balls in total. And then this one is 10 and 8, that gives him 18 balls in total. And then this one is 10 and 6, that gives him 16 balls in total. And then this one is 11 and 6, that gives him 17 balls in total. And this one is 12 and 4, that gives him 16. Alright, so these are the numbers that we are obtaining here. So you can see, remember he was saying he cannot buy less than 16. It is 16 or more, and you can see here that the numbers are 16 or more. So the question said, what is the maximum number, the largest, the greatest number of balls you can buy? So if we're answering that part now, part A, let's try to create this to answer the questions. So part A, you can all see that it is 18. You can buy a maximum number of 18. And then part B now says what, let's go back to the question. We are very good on time. Right, it says after using the balls, he can sell golf balls for 10 cents and tennis balls for 20 cents each. So 10 cents each for golf balls, 20 cents each. What is his maximum possible income from sales? So let's go back. So we know 10 cents for golf, 20 cents for tennis. Right, so now what you just need to do is just take the value of x multiplied by 10 and take the value of y multiplied by 20 and see what will this give us. That's 90 plus 160, that is $2.50. And then here we have 100 cents plus 160, this gives us $2.60. And then here we have 100 plus 120, which is $2.20. And then here we have 110 plus 120, which is $2.30. Here we have 120 plus 80, which is simply $2. And we can see that the winner is this 10 golf balls and 8 tennis balls, which will give him a profit of, a total sales of 260 euros. You get 260 euros after selling them. So we have answered our question from extracting the inequalities, drawing the graph, finding the feasible region, and then finding the sets of points inside the feasible region, and then maximizing our objective function. So our objective function in this case was to maximize sales after, maybe we say in business terms, we say the residual value of an item, that is the value that it is left with after we have used it to the point where you say, I can no longer use it, I need to dispose of it. You sell it at its residual value. So he wants the maximum amount he can get. So linear programming gets you the optimum operating numbers. So these solutions that we have, these numbers, we are saying it makes sense to buy 9 and 8, 10 and 8, 10 or 6, then 11, 6, 12, 14. And then it is even more economical if he buys 10 golf and 8 tennis, both as in the maximum number of balls as well as the number of balls that gives him the maximum sales when he is getting rid of his balls after he has used them to beyond their suitability for maybe practice or games. So that's linear programming in short. It included legitimate, proper ways of deciding on where to shed, irrespective of a line, up to the point you get your feasible region. So maybe something that I need to re-emphasize is, if your inequality only has the sign less than or just greater than, you draw a dotted line. You draw a dotted line, and then you do not pick when you're in the feasible region. So your feasible region also include the bold lines, but not the dotted lines. So anything on this line cannot be picked, right? So which means this point cannot be taken, this point cannot be taken, but this point we took it because it's on a bold line as well as this one. So that's what I'm explaining right now. Right, so that marks the end of our lesson. I hope it helped you. So if you need any more explanations, you need another question, or you have a question from a particular paper, just let me know on the comment section. I will get back, have another go until you guys are satisfied and confident in answering these questions. Good luck and cheers.